You are just in time to hear from Clint Berry. He is the co-founder and CTO at Weave. They have been unifying business tools, data, and all channels of communication into one smart platform. He's going to be talking to us today about strategies used to move communications platforms into Kubernetes and the benefits of doing so. The title of his talk is The Quest for a Cloud-Native Communications Platform. Take it away, Clint.
Thanks, Travis. Appreciate it.
Big round of applause for Clint.
Thanks. So cloud native. First, let me tell you a little bit about me. I mentioned I was the co-founder of Weave. If you're familiar with the cloud native ecosystem, don't confuse us with a company called Weaveworks. They actually have a networking solution for Kubernetes called Weave, and it gets really confusing, especially since we host the Utah Kubernetes meetup. I had one guy that came and he was just drilling me all these questions about Weave networking stack, and I was like, dude, I don't actually know because we don't use it. And he's like, you don't use your own product? And I was like, oh, we're not that Weave. We do phone system for dentists. It's less sexy. So he was a little bit disappointed. I don't think he ever came back to the meetup either, but that's all right. Passionate about DevOps and all things open source. Love FreeSWITCH. I love to wakeboard when I'm not fat, so it's been several years since I've loved to wakeboard. But it's fun when you're not overweight. I want to tell you a little bit of story and background about how I came to Weave, to give you a little bit of context on what we're trying to accomplish, so you can at least understand it a little bit more. And so I had worked with the now CEO of Weave at a previous company, and he came and presented this idea to me. He said, I want to provide small businesses, and particularly dentists, at least to start, with a phone system. Is that showing up on your stupid Slack? It's probably those jerks down there messaging me. Hang on one second. Quit. There we go. Wanted to provide phone systems to dentists with software that integrated with those phone systems, so that you could get click-to-call and call recordings and all that stuff right in the software, but also integrate them with their practice management system, which is like the dental equivalent of an EMR. So that way, when their patients call in, our software pops up and gives them all that contextual information about their family. Are they overdue for cleanings? All this stuff that you'd want to know if you're a dentist on your phone system. Not in this group, not particularly novel, but in dental, it was actually amazing. Like, people get blown away by it. Like, wow. It also, he told me the prototype that he had built, he had a consultant build the prototype, he built it in FreeSWITCH. And at the time, I was just like a hobbyist. I had a FreeSWITCH in my basement that powered like a home phone system. I'd messed with Twilio a little bit. So of course I was like, this is gonna be easy. This is gonna be simple. This is simple. I'm a web developer by trade, and I thought, how hard could it be, right? Easy button. Well, I was wrong, very, very wrong actually. So I came out to ClueCon for the first time 7 years ago, and came out a day early for the FreeSWITCH training that they offered at that time. And it was actually taught by the CEO of 2600 Hertz, Darren Shriver, at that time. So it was actually a really cool, unique opportunity to have him teach the class. I think even Travis was in there for half of it that time, which was really cool. So just all these like brilliant people teaching an intro to FreeSWITCH class. And that was the beginning of feeling like this a lot. Just getting blasted by the fire hose of VoIP. It was a lot different than web development. It scaled a lot different than web development. It was significantly harder than web development. And so this was probably on a good day. On a bad day, this is kind of gross, sorry. This is what it was like on a bad day. The fire hose just kind of ripped your face off. And so, it was a lot of 80-hour weeks for those first 3 years. A lot of sleep. Sorry, I'll get that grossness off the TV. A lot of sleeping at the colo. It was sacrificing vacations to make sure the system was up. It was when I was in the shower, propping my phone up against the shower walls to make sure that the system was running, so I would never miss a moment. Massive anxiety, gray hair all the time. But we came out of it. We hired some great people, some great talent. And now this last month, we just passed 11,000 locations. And when I started 7 years ago, we were at 30. So it's a lot of fast growing. In the last 4 months, we've averaged over 500 new locations per month, to give you an idea of the scale of how Weave is growing. So it's super fun, but also super scary, because the single hardest part of the technology is scaling the communication infrastructure. That's the difficult part, the most difficult part that we run into, even though we have a significant amount of software. So kind of our business model that we're trying to do is we built this, we'll call it a CPaaS. What did Anthony say? It's like, I don't want to be in the ass family. Well, I'm just embracing it. It's a CPaaS, but it's internal. We build an internal communication platform, and we have all these tools that we build for small businesses around it that leverage it. So like payments has a text-to-pay thing that they built, leveraging the communication stack. But the communication stack, even though we have a lot of software, is the most critical. So let me talk a little bit about cloud native and what I mean when I say cloud native. This is kind of the definition that I'm using when I talk about cloud native. Basically, it's services that are packaged in containers, deployed as microservices, and then managed on elastic infrastructure. And so Evan touched on this a little bit. I think it's important to understand the why, though. I mean, there's a lot of tooling for VMs out there. There's a lot of ways to accomplish a lot of these things with VMs. But I think that cloud native gives, it's like the next generation and is even better than VMs once you fully adopt it. And I think the number one most important reason why you want to go cloud native is speed. And I'm not saying speed from like the service, it runs faster. I mean speed of getting your business logic to production faster. So a lot of us, not every one of us, I'm sure, but a lot of us work for companies that aren't necessarily curing rare diseases or building rockets. We're building software, and the barriers to entry are getting lower. And thanks to Anthony with SignalWire, they're getting even lower to break into our space. So thanks a lot, Anthony. But that's okay. So I guess what I'm saying is speed has to be the differentiator. In a lot of ways, we're competing against teams that are 2x, 3 times as big as ours. And if we can have an ops advantage in getting our products to production faster, making our development cycle faster, that's a big advantage. And then next, I think, obviously, is availability. A lot of these cloud native orchestrators give you a lot of availability out of the box, health checking, self-recovering, things like that. Margin, obviously, the Fortune 500 companies love margin. I think that's why you see the fastest adoption of DevOps in Fortune 500 companies is because of getting that extra margin with containers. And then consistency, one way to deploy, one way to ship, which I think is great. So I want to tell you a story from 2015. In 2014, we started migrating our Python Django monolith service to microservices. And at the time, we were just taking our microservices and running each one of them on a VM. And even though we had thin provisioning of RAM and CPU, that you can still imagine the kind of overhead that takes, especially since our backend language that we use at Weave is in Go. So like the compiled binary was actually like only taking up 10 to 20 megs of RAM, and the VM was like Ubuntu for every one of these, and I need 3 for redundancy. So we knew we wanted to use containers, but we had all these questions about how we were going to adopt containers. And I think these are all the same questions that people were asking back then as they were trying to adopt this container workflow. And ultimately, we did research on Kubernetes, Mesos, Docker Swarm, and my chief architect and I went to a conference called QCon, not ClueCon, QCon, run by the InfoQ guys, and this guy was a keynote. And his name is Eric Brewer, famous for coming up with the CAP theorem. So he's a pretty famous computer scientist. He's been working at Google since 2011, and at the time was the VP of infrastructure at Google, and he was in charge of the Kubernetes project. And he gave a whole bunch of great insight onto why Kubernetes was great, and I loved this quote that he put. So he talked about the history of Kubernetes and how these 2 engineers wanted to take what Google called the Borg and make an open source version of it. And this was a quote from the formal Google head of infrastructure. So let me get this straight. You want to build an external version of the Borg task scheduler, one of our most important competitive advantages, the one we don't even talk about externally, and on top of that, you want to open source it. Like, that's a pretty neat vision to have, to take this big competitive advantage and expose it to the world. And I think Google is getting a lot back from it with their GKE engine and things like that. But what a cool idea. He ended up selling us big time. We went back, stayed up all night, spinning up Minikube, experimenting, proof of concepts to get things migrated over as quick as possible. And we loved it. And so, Evan won't recommend an orchestrator, but I'll stand up here and actually strongly recommend Kubernetes as long as you have at least 1 or 2 people on a DevOps team full-time. If you're at that scale, I think you're going to see a lot of benefit of Kubernetes. If you're not at that scale where you have full DevOps team, it would probably be a little daunting because there's a lot of work involved. And he mentioned that the learning curve is super high. But if you are a growing company and you have the staff available, Kubernetes is basically, in my opinion, is the winner. They have one of the highest adoptions. The activity on GitHub is incredible. Top 3 GitHub projects. So we migrated. We've now migrated. We still have some out, but 95% of our software workload is in Kubernetes, not of the communication platform, but of the software is in there. And we got all these benefits, right? All the things that everyone knows about from a cloud-native ecosystem, this is what you get, and it's exciting. But phones need that too, right? Phones should have this stuff too. And Jonathan from 5.9 kind of touched on this, right? He said, it should be just as easy to do the phone stuff as it is the web stuff. And we absolutely believe that, and we're trying to push that way with this cloud-native migration for our phone communication infrastructure. So from a high level, here's kind of this is a very high level, but our architecture for the communication platform, at least the VoIP side of things. You can see we have our SIP proxy that lives at the edge, and an RTP proxy that lives at the edge, and then any number of SIP router or registrars underneath, and a bunch of FreeSWITCH media boxes underneath. And then everything's powered by supporting microservices under that. And then our primary data store for in the critical path is Couchbase because of its multi-master and high availability. So we want to get all these things and are pushing to get all these things into our cloud-native ecosystem. So here's some of the hurdles that we've run into in trying to do this. Network, state, and service discovery are a lot of the things that make this hard. But I think things are getting better, as you can see, as we'll talk about. So starting with network, and Evan mentioned this, a little bit later, something he mentioned, but for Kubernetes, the networking layer, the overlay is actually a plugin. So there's lots of different options for how you can use networking in Kubernetes. If you're using a cloud offering, I think most of those are based on Project Calico. If you install it with bare metal, the default is Flannel. And they've seen so much improvement over the last 2 years as far as latency and overhead. And it's exciting that now real-time communication is not the only thing that needs low latency, so there's a lot of pressure to make these things better, and they're getting there. But in the early days when Flannel had a lot of overhead in the early days, it just wasn't good enough to run a real-time communication because of the networking overlay. And so you'd see a lot of this, where a Kubernetes node gets spun up, and you're like, okay, I'm going to install FreeSWITCH, have it in a container. I'm putting it on the Kubernetes node, but I'm just going to do host networking and bypass the overlay completely. And then I'm just going to take up all the resources on that box because you can only install one thing if you're using host network. And I get why people were doing that. At least your scaling of VMs is consistent, right? It's all Kubernetes. So it's I just need more Kubernetes nodes. That's fine. It's a consistent deploy thing. But I don't think that this is the cloud native way. I think this is more of a hack to get it on. And it's kind of like a glorified VM in some cases, right? So I don't think this is the goal, and this is not where we want to be. So networking solution 2 is like, look, just let's embrace the overlay, because we're finding that the overlays actually can work now in small amounts. You heard Evan mention you have a couple options. You can shrink your size of your FreeSWITCH boxes so they don't have to handle as much, which I think is the route you should go if you're going cloud native. Just add more FreeSWITCH boxes, and the containerization will take care of it. So embrace the overlay, but you still have to expose that. You have to expose your network from outside of the Kubernetes box, right? And so in some cases, if you're doing it the Kubernetes way, it can be a little bit difficult. Like ingress definitions don't support like port ranges, things like that. And so you'll see that a lot of people are still using a host network for the edge thing, but then they have a bunch of other services underneath, like SIP routers that can still run on the same node and work on the same overlay, which is exciting. But this presents some awkward scaling issues as well. Like, oh, I need another RTP proxy, so I actually have to spin up a new node, because I only have one of them. And then you're like playing this delicate game. Well, how big should the node be? I don't want it to be too oversubscribed, and I'm going to have all these extra pods or whatever. And so I still don't think this is ideal, even though this is kind of where we're at. But I think in the future, what we're trying to do at Weave is the network solution 3, which is actually just to write a custom ingress controller for real-time communication. And that probably sounds a little bit daunting, but I think once you become proficient with Kubernetes, you realize it's not so bad. They have a lot of libraries to help you do these things. And so I think the goal here is, hey, look, I want to write a custom ingress controller. We're going to just let the scheduler handle it. We'll make sure that we put taints and tolerations in there so that we don't get more than one on the same box. But they can run anywhere, on any node, and then you get all the advantages of like treating it like one giant computer, and you just scale it up, which is really exciting. So this is where we're trying to head right now. Not there yet, but close. You can follow the progress of networking in general on the special interest group. So something that's really cool about Kubernetes is that special interest groups for everything you can imagine, and the network one is very active. They have a weekly call, and you can hop on and just kind of see their progress, how they're improving the overlays, how they're doing service definitions, things like that. So it's a great thing to follow if you're interested. Moving on to state. We haven't solved all of state. If you're not familiar with these concepts, I'll just touch on it high level. Stateless services, typically you treat as cattle, right? Ephemeral, or what's the right word? Immutable infrastructure. So that if one crashes, you don't bring that one back up, right? You just create a new one. It's cattle. And then you have the pets, like if it crashes, it comes back. You bring that same one back up. It probably has state in it. And it has an addressable IP that doesn't change. So our goal is to make Kamailio, I've been in this 7 years, I don't even know how to say it still. Someone can correct me if I'm wrong, but making Kamailio and FreeSWITCH as much as possible a cow. We want to make it cattle. And the reason is because we want to be able to spin up as many as we want, as fast as possible, and kill them whenever we want. And that's the ideal state, right? We are not there yet, but we're working on getting as much state out as possible. The first thing that we did for the proxy, we use Kamailio with the dispatcher module. Let me give you the high overview of how a pod works. One of the reasons we loved Kubernetes is this concept of the pod. And I think this is one of those learnings that came out of Google, which I think is really exciting. The pod is the lowest primitive in Kubernetes. It's not container, it's pod. And so a pod represents almost like a local VM, right? So you can run multiple containers in your pod, and they have access to localhost. And this gives you a lot of power, one of which I'll talk to you about in a minute. And then you also have config maps as a primitive in Kubernetes. So as you can put configuration in, and any pod can access that configuration. And so in this case, what we did to take some of the state out of the proxy and make it so that it was more dynamic is we created a config map that shows all the routers, the SIP routers for Kamailio to hit at the edge proxy. And then Kamailio runs in a container inside of the SIP proxy pod. And then we mount that config map as a volume, which just puts it as a file inside of that pod as well, which Kamailio can access. And then we wrote a little sidecar in Go that watches for changes. And if we ever change that config map across the board, it watches the change, and then it changes it fires a reload on the Kamailio config, and now it knows about the new services. And so this is like a really common pattern that people use to mount configuration and make it a little bit more dynamic in the Kubernetes way, which is really cool. Auth state, auth is a big one. We've RPC'd auth itself, so that it hits an auth pod in Kubernetes, comes down, hits auth, which then hits Couchbase, and then does that. But we still store, currently we are still storing the state of the registrations inside of Kamailio, inside of the router. We would like to get out of that. I kind of actually fought hard against DMQ, the module DMQ, because I was like, why would we use some Kamailio specific distributed state engine when there's like so many out there, like try Cockroach, or we could use Couchbase, or we could use Postgres BDR, something that's built for it. And the SIP engineers assured me that it can handle the scale, and they were absolutely right. DMQ has been impressive. Like it handles the scale just fine, and we distribute all registrations across all routers, and it works great. When you spin up a new router, you give the DMQ addresses, it goes and gets all the registrations, puts them in there, and then gets all the events updated as it goes. And so you basically can load balance to any of them, and it works, which is great. But to do that, unfortunately, you have to run stateful sets in Kubernetes. So this is a primitive in Kubernetes designed specifically for running stateful applications. And that means what happens is if a container dies in Kubernetes, it will restart up and get the same IP address. It doesn't just create a new one, so it doesn't treat it like cattle. And this is a good option if you need to run stateful applications, but I think the future of where we're going is what we call the operator pattern. And the reason why I say this is because every stateful app kind of has its own unique way that it needs to scale in a lot of ways, right? Like we're dealing with real-time communication. We're dealing with SIP and registrations. We need to scale that in a certain way, and we need to be knowledgeable about it. Like there's no way to create like a generic stateful scaling system. And so one of the cool things about Kubernetes is it lets you add different object types to the API as if they're Kubernetes primitives. So you could literally say, and that's what a custom resource is, but you could literally say, I now am I want an object to exist called a SIP router. And that's a thing. I just defined it in Kubernetes. Now it knows about it. And then I can hit the Kubernetes API and say, create new SIP router. And then you have an operator that exists up in the cluster and watches for those events and says, oh, yeah, I see he's trying to create a SIP router. And it knows what to do. And it will create a new SIP router for you and do all the config for you. And this is kind of the way stateful applications are moving. Like you'll see this in Vitesse is a native database cluster that runs inside of Kubernetes based on MySQL cluster. It uses an operator now to do its scaling. And you'll see that Couchbase has one as well. You're seeing a lot of stateful applications go that way, which is exciting. I want to talk about a little bit of the anti-patterns that we're fighting against here in some of the VoIP infrastructure. First one, using large XML files or domain-specific languages is definitely not the cloud-native way, right? We want to configure via API or RPC. And that was a struggle at first, especially just the way we had done FreeSWITCH. We had a lot of XML configuration and moved lots of it to either curl, HTTP curl or WebSocket, which is good. But Kamailio is the same way, right? Like they have a domain-specific language to interact with it, and it's a config file. But we want to try to get away with that, do more RPC or HTTP requests to configure it on the fly. Treating containers like mini VMs, I think, is definitely a big no-no if you can get away from it. Like we don't need systemd anymore. We don't need all that stuff that comes with a Linux box that you need to run. Like get rid of it. Make your container small. The runtime, Kubernetes is going to control the spin up and running of these applications. So don't try to do VM stuff in your container. And then the other two maybe don't have application. 2 minutes. Okay, the future, I'll just wrap up with some of this. I think you're going to see a lot more operators coming out for stateful sets. We are going to be trying to create a bunch of operators that we will open source. My goal is to open source the entire communication stack. So we'll create operators for registrars, whatever else that we use, media servers, and hopefully that will benefit all of you. I think you're going to see more databases that become Kubernetes native. Vitesse is growing in popularity, which is cool. Cockroach is like Google Spanner, the open source version of Google Spanner, which is gaining a lot of popularity. And then, of course, we love Couchbase. At least I do. My phone team maybe doesn't love it as much as I do. Yeah, Josh is shaking his head. No, I love it. And then I think one of the ultimate goals I think would be cool to get to, and I think this is, maybe this is a pipe dream, I don't know. But what if you could, inbound call comes in and you had such a lightweight back-to-back user agent that it could spin up just a function, and every single call that came into your system was a function as a service, and you defined all your routing. I think that would give you a ton of benefits from even faster deployments, easier scaling, right? You just spin up more containers when you need to handle more functions. And then you could do cool things like canary testing the routing a lot easier. And again, all these things are doable in other ways, but I think the cloud native ecosystem makes them a lot easier to do. Like you can, when I say canary testing, imagine if you could change your routing logic for 1% of your traffic and make sure it didn't have any errors, things like that. Other things to discuss, I've got a lot of blog post drafts that I'll be posting over the next few months around all this stuff, but metrics and open telemetry for our great cloud native solutions for web stuff that could easily apply and do apply on our system to FreeSWITCH and other parts of our phone infrastructure. Security stuff, service meshes, Jonathan mentioned how they don't work well with UDP and TCP, and that is very true right now, but I think there's some movement to help that along. And then leveraging gRPC, other modern protocols. For a long time, we used Jansen RPC module in Kamailio, which was written by an old FlowRoute employee, and it was great for a long time, but it just had some weird bugs, right? It would stop working, and like gRPC has a lot more safety built into the protocol, and so we need to try to figure out how to get more of those things into our infrastructure. And then so there's some really cool auto-scaling strategies. In Kubernetes, you can auto-scale based on custom metrics. So you could watch the Prometheus metrics for how many calls are on any given FreeSWITCH box, and you could auto-scale based on the number of calls, which is really not necessarily just CPU or memory. So those are exciting. If any of this sounds appealing to you, definitely join our team. We're looking to grow as fast as possible. We've doubled 2 years in a row on size and are looking to double again next year. So join us. My time is up. Sorry, I went a little bit over. That's it.
All right, big round of applause for Clint Berry.